A bottle opener can generate a force equivalent to a 20-ton elephant stepping on a grain of sand. Bottle openers are an essential tool in our kitchens, but few of us know the fascinating science behind their functionality. From the humble manual opener to the sleek electric device, these instruments rely on fundamental principles of physics and materials science. So, let's dive into the world of bottle openers and uncover the surprising secrets that make them work. Imagine you're at a party and you need to open a chilled bottle of soda quickly. You reach for bottle opener, and with a few swift turns, the cap comes off with ease. But what's happening beneath the surface? The answer lies in the interaction between the opener's mechanics and the bottle's material properties. The most common type of bottle opener is the manual screw-top opener, which uses a screw-like mechanism to loosen the cap. As you turn the handle, the screw threads into the cap's threads, creating a frictional force that eventually overcomes the cap seal. But that's not the strangest part. The force required to open a bottle can be surprisingly high. A typical bottle opener can generate a force equivalent to a 20-ton elephant stepping on a grain of sand. To put this in perspective, consider the following. The force required to open a bottle is comparable to the force needed to crush a small car. This is because the cap is under significant pressure, which must be overcome by the opener's mechanical advantage. But how does the opener's mechanism produce this incredible force? The answer lies in the design of the screw threads and the material properties of the opener and the cap. The screw threads are typically made of a hard, wear-resistant material, like stainless steel or titanium. As the screw threads engage with the cap's threads, they create a system of gears that amplify the force applied by the user. The mechanical advantage of the screw threads can be calculated using the principle of leverage, which states that the force applied at a distance from the fulcrum is amplified by the ratio of the distance to the fulcrum. In the case of a bottle opener, the fulcrum is the center of the screw threads, and the distance from the fulcrum is the length of the screw threads. By designing the screw threads to have a large mechanical advantage, the opener's manufacturer can reduce the force required to open the bottle. But what happens if the opener's mechanism fails or is damaged? In that case, the bottle opener may not be able to generate enough force to open the bottle, or it may even break under the pressure. This is why it's essential to choose a high-quality bottle opener that can withstand the forces involved in opening a bottle. A good bottle opener should be able to generate a force of at least 10-15 newtons to ensure reliable operation. To give you a better idea, consider the following. A typical adult can generate a force of around 100-150 newtons with their hands. So, if a bottle opener can generate a force of 10-15 newtons, it's equivalent to about 6-10% of the force a human can apply with their hands. This may seem like a small fraction, but it's actually a remarkable achievement considering the size and weight of the opener. In conclusion, the science behind bottle openers is more complex and fascinating than you might have thought. By understanding the fundamental principles of physics and materials science, we can appreciate the ingenuity and design that goes into creating a simple yet effective tool like a bottle opener. So, the next time you use a bottle opener, remember the surprising science behind its functionality and the incredible forces at play. If you found this fascinating, subscribe for more incredible stories like this. Want to learn more about the science behind everyday objects? Hit subscribe and join our journey of discovery. Want more mind-blowing facts? Hit subscribe and join our journey of discovery.